Hello everyone. In this lecture, I am going to show you how to calculate the center of mass of a composite system. To understand what is a composite system, here I am considering a reference system, that is this I am taking it as x-axis, this I am taking it as y-axis. So here I am considering a frame like this. Let me call distance from this origin to this point I am taking it as A, and this height also I am taking it as A. And mass of each plate, I am taking this each plate as m only. Mass of each plate is m. I wanted to find out what is the location of center of mass of m1, m2, m3. This configuration. All these are planar bodies, extended bodies. This I am going to do it by decomposition method. Decomposing means this complete diagram I am taking as a combination of plate number 1, whose area, let me call it as A. Area of this plate I am taking it as A1. Area of this plate I am taking it as A2. And area of this plate I am taking it as A3. And by symmetry I can simply say that this is a rectangular plate, no? Or maybe square, whatever it may be. It is a regular shaped body only, because of which exactly its center of mass will be located exactly at the geometric center of geometry only, center of symmetry only. So let me call location of this, I'm calling it as C1, center of mass of this plate. And similarly, center of mass of this plate is located exactly at its center. Let me call it as C2. And similarly, location of center of mass of this plate, I'm taking it as C3. Let me call distance from here to here is A by 2, and this distance also A by 2. Okay, so as long as the density of all these plates is same, uniform density, and mass is also same, then what is the alternate way? Instead of taking m1 x1 something like that, instead of doing integration, we can solve it like this. Center of mass of this composite system C is given by, in terms of its area, C1 into A1 plus C2 into A2 plus C3 into A3 divided by A1 plus A2 plus A3. This I wrote it in terms of what you call it as area of each plate. What are C1 is the coordinates of center of mass of A1. C2 is the coordinates of center of mass of A2. And C3 is the coordinates of center of mass of A3. So if you want, what is the x coordinate of center of mass? X center of mass is equal. So C1, what is the x coordinate of C1? That I am calling it as Cx1. That is x coordinate of center of mass of A1 into A1 plus Cx2 into A2 plus Cx3 into A3 divided by its total area, A1 plus A2 plus A3. So I am applying this concept over here, and let me check whether we are getting proper answer or not. So from geometry, distance from here to here is A. Distance from here to here is A. That means distance from here to here will be how much? A by 2. So first I am finding the location of C1. What are the coordinates of C1? C1. Distance from here to here is A by 2. Half of the distance is A by 4. X coordinate is A by 4 and Y coordinate also A by 4, because distance from here to here A by 2. Similarly, what are the coordinates of C2 for this body? Okay. So distance from here to here is A by 4. Already distance from here to here is A by 2 plus A by 4. Altogether how much you will be getting? A by 2 plus this is A by 4. Extra A divided by 4. So 3A by 4. So x coordinate is 3A divided by 4. and y coordinate height, distance from here to here. This total height is a by 2. Half of this is a divided by 4. These are the coordinates of center of mass of A2. Similarly, coordinates of center of mass of A3, that is C3, is given by, that is this. So it's geometric center. So distance from here to here is a by 4, and again this is also a by 4. But distance of this point from here to here is how much? Already this is a by 2. A by 2 plus a by 4 is how much? 3a divided by 4. 3a divided by 4. That is y coordinate. Sorry, I am writing it in place of x center of mass. First I should write down x center of mass. X center of mass is distance from here to here. Distance from here to here is a by 4. X coordinate is a divided by 4 only. What is about y coordinate? A by 2 plus a by 4, that is 3a divided by 4. So these are the coordinates of center of mass of each and every plate. So for this composite system, if you want x coordinate, how do you going to write it? X center of mass is equal to Cx1. X coordinate of A1 is how much? A by 4, center of mass coordinates. So a divided by 4 into area of this plate is how much? Distance from here to here is a by 2. A by 2 into a by 2, a square divided by 4. A square divided by 4. Plus, by taking this as origin, I am calculating. And Cx2, x coordinate of center of mass of second plate is how much? 3a divided by 4. So 3a divided by 4 into, what is the area of the second plate? A by 4, a by 2 into a by 2. Length, breadth, both are same. A square divided by 4. Plus, for Cx3, x coordinate of center of mass of third plate is how much? X coordinate a by 2. A divided by 4 into area is how much? A square divided by 4. Total divided by total area, A1 plus A2 plus A3. All are of same area only, because of which 3 times the area of each plate, that is A square divided by 4. Okay, now all through numerator and denominator, a square by 4, a square by 4, a square by 4 is common, so I am cancelling it out, cancelling out. So what are you going to get here? That is equal to a by 4 plus 3a by 4 plus a by 4. A by 4 plus a by 4 is 2a by 4. 2 plus 3, 5. 5a divided by 4 divided by, here we have 3. Therefore, x coordinate of center of mass, x center of mass of this composite system is given by what you will be getting? 5a divided by 12. 5a divided by 12. Similarly, you can go for y center of mass. You take it as an assignment and you calculate. Now, in a place of Cx1, you should use Cy1. y1 for this one is how much? A by 2. For this also a by 2. This is for 3a by 4. Like that, you can calculate. This is the overall thing related to calculation of center of mass of this composite system. Okay. Now, in some situations, the question may be framed like this. What if some portion is removed? That is, for that purpose, I am drawing this diagram. So, same configuration. I am taking here. I am taking this as y-axis, this as x-axis, and this is y-axis. Again, I am considering a square frame only. This is a square frame of side length A. So from this, he is removing a small or 1/4 of the frame from this portion. This portion he is removing. Now, when it is removed, how does the configuration look like? The configuration looks somewhat like this. Okay. So for this system, what is the location of center of mass? So to answer to this kind of questions, okay, first what you should do is, out of symmetry directly I can locate the center of mass of this system exactly at the center. And what are the coordinates of center of mass of this given system? If this total length is a, half of the distance is a by 2, and y coordinate also a divided by 2 only. Now, I know what is the location of center of mass of this portion which I am going to remove. Out of symmetry, directly I can put it exactly at the center only. So distance from here to here is a divided, the total distance is a, half is a by 2, half of that is a by 4. So distance from here to here is a by 2 plus a by 4, 3a by 4. So C1 coordinates, I am taking it as 3a divided by 4, comma, and y coordinate also 3a divided by 4 only. What is C1? C1 is the center of mass of the portion which I am going to remove. Okay, and area of this total plate, that is A, is equal to how much you will be getting? A square only. And area of this portion which I am removing, that I am calling it as A1. Area A1 is equal to what you are going to get? So distance from here to here is a by 2. A by 2 into a by 2 is how much? A square divided by 4. Then the center of mass of this system after removing this plate from this square plate, that is, let me call it as C1, it will lie, let me call it as somewhere over here, C dash, I'm not sure. Okay, so C dash is given by, after removing, is equal to total actual center of mass of this system is how much? C into area of the frame minus whatever the portion you are removing, you should subtract it, into coordinate center of mass coordinates. So C1 into area of that plate, let me call it as A1, divided by A minus A1. This is how we will solve. So I am applying to this situation. Actually, I want x coordinate of center of mass only. Therefore, x dash center of mass is equal, that is x coordinate of this C dash is given by C into x coordinate of C is how much? A divided by 2 into area of this plate is how much? A square minus Cx2, that is C1. What is C1? X coordinate of C. C1 is how much? 3a divided by 4. 3a divided by 4 into what is the area of the portion? That is A1 is how much? A square divided by 4 divided by A1 minus A2. A1, that is A is how much? Area of this plate is how much? A square minus A1 is how much? A square divided by 4. Now if you simplify this all through this, A square is common. You can cancel out A square. Then what you will be getting? A divided by 2 minus 4 4s are 16. 3a divided by 16 divided by, already a square got cancelled. 1 minus 1 by 4 is 3 divided by 4. Okay. So if you calculate it, therefore x dash, that is new coordinate of center of mass of this remaining portion, x coordinate of center of mass of the remaining portion is given by a divided by 2. This is 16. If you take LCM, 8. 8a minus 3a, 5a. 5a divided by 16 divided by, okay. This if you calculate it, how much you will be getting? 3 divided by 4 only. Denominator is 3 divided by 4 only. So if you calculate it, how much you gonna get here? 4 1s are 4 4s are 16. Am I right? So 5a divided by 4 3s are how much? 12. So whatever we got here, this value is nothing but how much? 5a divided by 12. Okay, so x coordinate of center of mass is 5a. This is consistent with this because this configuration and this configuration are same. Okay, so this is how we can calculate the center of mass of composite system by considering their areas. That is case number 1. In second case, what we did, what if some portion is removed from that system? This is how I calculated x dash system. In a similar way, you can calculate for y dash center of mass by taking this same procedure. Here, in the place of C, what you should substitute? Y coordinate of A, and C1 means y coordinate of A1. Like that, if you solve it, you will be getting the y center of mass also. That you take it as a homework. Now, I am going to extend it further. This is step 2. This is step 1. I want to extend it even more somewhat further. That is step number 3. What I am doing is, I am considering a disk. Let me call it as this is a disk. Okay, this is a disk. Okay, so this disk from this disk of mass, let me call it as M, and radius, let me call it as R. So what is the location of its center of mass out of symmetry? I can say that it will be exactly at the center only. So this I am taking as x-axis, this I am taking as y-axis. Okay, now from this disk I am eliminating a circular portion like this. I am eliminating a circular portion like this. Let me call the area of this circular portion, the radius of this circular portion I am taking it as r by 2. This total radius is, let me call it as r. Then I am eliminating a small circular strip of radius, let me call it as r by 2. Now I wanted to calculate what is the location of center of mass of this configuration after removing. Okay, after removing, same method I am using. Out of symmetry, first you should find out what is the center of mass of complete disk. What are the coordinates of center of mass? So by taking the origin at the center of the circle, okay, initial coordinates of center of mass of this disk is 0 and 0 only. And what are the coordinates of the portion which I am eliminating? That is C1. That is C1. So this is symmetric about this x-axis. So that means as it is symmetric about the x-axis, its center of mass should lie on the x-axis only. Okay, so because of which, as it is lying on the x-axis, this already I have taken it as origin. So distance from here to here is nothing but the radius of this disk. How much it is? R by 2, because of which this distance is R by 2. It is lying on the x-axis, because of which its y coordinate is 0. This is step number 1. And step number 2 is calculating the area of the given disk. A is equal to area of the complete disk is how much? Radius is R, no? So because of which what I can write? What is the area of the disk? Pi into R square. Next, calculating the area of the portion which I am removing, that is A1. A1 is equal to pi into, what is the area of this portion which I am removing? R square divided by 2 whole square is nothing but 4. So this is how we calculated area of each one. Now let us go back to this same formula. What is the CA minus C1A1 divided by A minus A1. So same thing I am doing here. I am doing it for x coordinate of center of mass, because anyhow y coordinate of center of mass will not shift over here. X coordinate of center of mass is given by A into C. A is how much? Pi R square into area into, what is the x coordinate of center of mass for this total disk? 0 minus, next C1 into A1. What is the x coordinate of center of mass of the portion which I am removing? R by 2. R by 2 into area of this strip is how much? Pi R square divided by 4 divided by A1 minus A minus A1. What is the total area of this disk? Pi R square. Pi R square minus A1. A1 is how much? Pi R square divided by 4. Okay. So if we cancel out pi R square, pi R square, pi R square all through this, this is anyhow 0 into something is 0. So pi R square, if you cancel out here, what you will be getting? R by 2 into 4, R by 8. Therefore x center of mass is equal to R by 2 into 1 by 4 is R by 8 minus R divided by 8 divided by, this value is how much? 1 minus 1 by 4, that is 3 divided by 4. That is equal to 4 ones are 4 twos are minus R divided by 6 you will be getting. Anyhow, out of symmetry, y center of mass is 0 only. Therefore, new coordinate of center of mass of the disk through which this circular portion is removed is given by C dash is equal to, what you can write, x dash is equal to how much you got? Minus R divided by 6, and y center of mass for the new coordinate system is 0. These are the coordinates of the disk, new disk from which this circular portion is removed. So this is how we calculate it. To make it somewhat complicated, what I am doing is, next step, in fourth step, what I am doing here is, whatever the portion which is eliminated, what I am doing is I am putting it on the right side of this disk. Let me draw it like this. So this is the actual disk. Okay, this is this disk only. So this take it as x-axis, take it as y-axis. This is y, this is x-axis only. So from this what I did, simply I eliminated this circular portion. this circular portion I eliminated. So whatever it may be the eliminated portion, that I am putting it on exactly on the right side like this. Okay, so this is the answer when this portion is removed and put somewhere over here. It is nowhere concerned with that one. Now what I'm doing is, whatever the portion that I removed from here, I kept it over here, touching the circle on the right side like this. Now I wanted to find out the center of mass of this configuration in which this portion is removed. That is, for let me assume that this portion is removed now. So let me strike it off. Okay, this portion is removed. Okay, so and this removed portion I put it on the right side of the circle, touching the circle like this, about the x-axis, symmetrical I placed it. Then how to calculate this kind of problem? Removed portion now added at some other position. Same method. What you do? This is the thing which is removed. So because of which you remove it, and this portion is added again, because of which you should add it. That is, therefore, x center of mass or center of mass coordinates c dash is given by, let me call it as in this case c double dash is given by, what you can write, total area A into its center of mass coordinates AC, and this portion is removed, no, minus A1 into coordinates of this center of mass, let me call it as C1, and coordinates of new position of this one, anyhow coordinates of this is this one only, exactly at this point only it will write. As is added, simply add it, A1 into this is a C1 dash divided by A minus A1 plus A1, because it is added over there. This is how you should do. Anyhow, A1 gets cancelled, because of which you will be getting C double dash is equal to AC minus A1 into C1 plus A1 into C1 dash. C1 dash is the coordinates of center of mass of this portion. So that only I am doing here. I'm extra coordinate that came here is C1 dash. What are the coordinates of this one? Because distance from here to here is r, distance from here to here is r by 2. R plus r by 2 is how much? 3r divided by 2. As it is symmetric about the x-axis, y coordinate is anyhow 0. So that I am including over here. Therefore, c double dash is equal to a, area is how much? Pi r square into c, coordinates of center of mass of this disk is how much? 0 x coordinate, because already here I showed it, minus A1 is how much? Pi r square divided by 4 into C1, coordinates of center of mass of this portion, which is I am eliminating from here, is how much? R by 2. Okay, into R by 2 plus A1. A1 means which I added here, same area, that is pi r square divided by 4 into, what are the coordinates of center of mass? X coordinate, 3r divided by 2. 3r divided by 2 divided by, so this anyhow minus A1 plus A1 gets cancelled. Total area is pi into r square only. Through this, what you can write, all through this, pi r square, pi r square, pi r square, pi r square gets cancelled. You will be getting pi r square r by pi r square got cancelled. So here what is left over? Minus r by 8, minus r by 8 plus this is how much you will be getting? 3r divided by 8 plus 3r divided by 8. Altogether what you are going to get here is, r by 8 minus 1 plus 3 is how much? 2r divided by 8, which is nothing but r divided by 8. Anyhow, y coordinate of center of mass is 0. Therefore, c double dash is equal to, what you are going to get? R divided by 8 comma 0. So the coordinates of center of mass of this new configuration. So when some portion is removed, it, so you subtract it. When some portion is added, simply add it like this. This is how we can calculate the center of mass of a composite system. For practice purpose, you solve this problem. Here what I am doing is, I am taking an object in this shape. Which shape? Let me call it a F shape I am taking. Okay, like this I am doing. Like this I am taking. So this is in the shape of F, English letter F. Okay, for this configuration I wanted to calculate what is the center of mass by taking this as x-axis and this side as y-axis, that is origin over here. So here I should give you dimensions, am I right? So height, distance from here to here I am taking it as, let me call it as some 8, and distance from here to here let me call it as some 6, and distance from here to here I am taking it as some 2. Okay, and this is 2 width for every section I am taking width as 2, this width also 2. Okay, this is symmetrically placed, assuming that this is symmetrically placed. Find the center of mass of this composite system. I'm going to give you a hint. How do you going to do? You take this rod as one body and this rod as one other body, second body 1 2, and this rod as third body, and find the location of center of mass of this body, this body, this body. Obviously for this vertical rod it is located over here, for this horizontal rod it is located over here, for this horizontal rod also. So combination of these three rods you take it as and find out x center of mass and y center of mass.